Hi, my name is Joseph Shariah, and I am from the ODD class of 2019 at Indiana Wesleyan University. And today I want to thank you for joining me. And the plan is to take some time to introduce faculty and students at IWU to the 3D printing process, and specifically the 3D printer here on campus. Although there are an incredible amount of applications for 3D printing in occupational therapy, this presentation is not aimed to discuss those applications. This is just going to give you the tools to start printing yourself and then to do more research to figure out how 3D printing will best help you in your journey as an occupational therapist. Our objectives today are to understand the process of fused deposition modeling, or FDM, 3D printers. We'll locate relevant 3D models hosted on the web to print later on. We'll learn how to assess necessary features to successfully print an item. And lastly, the goal is to learn how to operate the MakerBot Replicator Z18 on a rudimentary level, just to get us started. So when people ask me what is 3D printing, I do have to say it is a bit of a loaded question, because there are actually 7 different methods of 3D printing, which is also called additive manufacturing. And really, that just means the process of joining materials to make parts from 3D model data, usually layer upon layer. FDM printers work by utilizing thermoplastic filament, and this plastic is kind of bundled up into a wire type form. This plastic is fed into an extruder that has a hot nozzle, and that nozzle moves around on a build plate to create layers upon layers of plastic, as you can see in this photo here, to create a shape. And I wanted to show you the Smart Extruder Plus. This is the extruder that the Replicator Z18 that is on campus actually uses, and will create layers on layers until you come up with a 3D object. This is the MakerBot Replicator Z18. This is the printer that the IWU OTD program has. It has an impressive build volume with 11.8 by 12 by 18 inches. Now, average desktop 3D printers only have an 8 by 8 by 8 inch build volume. So it's an impressive build volume. It uses PLA filament only, and that's okay. We're actually not going to go into different types of filament on this. You should know it does not have a heated build plate. So it does make that first layer of adhesion a little bit more difficult, but there are ways to remedy that. This printer, unlike a lot of others, has a heated chamber, and the heated chamber works to prevent splitting of layers during a longer print time. Let's take a look at the 3D printing process. And so individuals they have the freedom to create or acquire a 3D printable model. In this case, we're just gonna focus on acquiring one. Then you take that model and you send it to MakerBot Print, which is a slicer. We'll go, dang it, okay. Check. Let's take a look at the 3D printing process. First, we'll acquire a 3D printable model. We'll find them on the web. You are welcome to create ones on your own. That does go out of the scope of this presentation. We'll then take that model and send it to MakerBot Print. Then from MakerBot Print, we transfer that design into a .MakerBot code. And that's the code that the printer can read. The printer cannot read just a design that's been hosted online. And lastly, we'll remove the print from the build plate, and if needed, complete any post-processing. 3D printable designs are created with computer-aided design programs, or CAD programs. You may also use CAD programs to edit a previously designed model. Of course, that depends on the license that model is released under. The file types that we'll see online are most likely going to be stereolithography files or STL files. You might also find .obj or .3dp files, but STL files are going to be the most common. For the sake of brevity, this presentation will just use Thingiverse.com to find a model. Thingiverse.com is a design community. It was created by MakerBot for discovering, making, and sharing 3D printable things. All designs that are hosted on Thingiverse can be downloaded at no cost, and most of the items are licensed under a Creative Commons license, which allows individuals to share the design, but you must credit the creator. Be sure to check the Creative Commons license under the Thingiverse page. Click the link and it'll take you to the Creative Commons website where you can learn how to appropriately credit the author. If you're interested in exploring other websites to find 3D models, you can look at all3dp.com's article on 33 best sites for free STL files and 3D printable models. Let's go ahead and introduce you all to the model that we'll be using in this presentation. This is a palm pen holder created by Makers Making Change. I have used this model when helping an individual engage in an art program in the past. You can scroll down and see the summary of the model. Learn about the Creative Commons license that it's released under. In this case, it's non-commercial, so we wouldn't be able to sell it to anybody after printing it. So you'll go ahead and download this file and save it in a place where you can find it when we upload it to MakerBot Print. Let's look at the folder that we just downloaded from Thingiverse. The creators of this item include the attribution card, so you could print this out if you were to display it in any public place. They have files here. This is the STL file for the actual item, and they do something different too. They even include a PDF with instructions on how to use this. You don't always get this much detail with a file that you'll download online. They mention the type of material that it should be used by. Now, looking at this one, it says ABS plastic. However, we don't have ABS plastic. So let's see what happens when we use PLA plastic. They do tell you the infill density as well, and the layer height, whether or not you need to use supports or a raft. The settings that they provide may or may not be best for the printer that we have, and so we'll learn more about that when we upload our item into MakerBot Print. You can click on this license text document. The license text document gives you a blurb that you can copy and paste into anything that you needed to print, or if you needed to give credit to the creator, and also includes a README document. This will also have some more information about the item itself. We are on the second stage now. We're gonna send this item that we downloaded to MakerBot Print. MakerBot Print is a slicer, and a slicer slices a design into layers, and those layers will be used to build up the part that we're printing. A slicer allows you to define the 3D printing parameters, such as supports, which we will talk about, layer height, extruder temperature, and more. And the slicer converts the STL file into a code that the printer can read. Printers don't read the STL or OBJ files. In our case, our printer needs a .makerbot file to read and print. Let's upload our file to MakerBot Print. You'll add your file I already have this on here. Let's look at the orientation of the model that we have here. Now remember, our printer prints layer by layer. What would happen if the item was put on the build plate like this? If we're printing layer by layer, it's going to be pretty awkward to print this, and it's going to be standing up on its own. This might be a difficult place for it to print to. So let's start by just making sure that the orientation is in an ideal manner. On the Orient menu, you can see that there's a place face on build plate. And let's go ahead and place this bottom face here on the build plate. And this is going to be the most ideal way to print it. A lot of times, the uploaders of an item might actually tell you what the best orientation is to print it in. Let's spend a little bit of time focusing on the print settings. Now, a whole lecture could be held on each of these settings, the balance, draft, or min fill settings, but let's focus on getting you printing. Press the gear for print setting, and you're not going to change the extruder type. Here are the 3 default modes that are provided to help you get started with printing. So the balance is just that standard mode, and then if you're looking for something that doesn't matter how durable it is, go with the min fill. There's draft, and you can learn more about these settings by going into them and pressing custom settings here. Now, one setting that is not actually included in any of these is chamber temperature. I want to encourage you all to experiment with chamber temperature. The MakerBot manual says that the chamber temperature allows the extruded PLA to cool more slowly during printing and can help prevent cracking between printed layers of plastic. They suggest putting it at 35 degrees. I want to encourage you to also spend some time with each of these settings. Let's spend some time talking about infill density. Infill density is quantified in percentages. You can change it on the custom print mode menu here, or just in the general print settings. 3D printed parts are not usually printed solid. To use less material and decrease the print time, objects are filled with a low density structure called infill. And infill is simply a repetitive structure or pattern that's used to take up space inside of an otherwise empty 3D print. Most slicers set the default models to 20% infill, which is adequate for the majority of printing applications. If you're looking to save time and just using a prototype, try something like 10%. If the part has to be screwed in or mounted, 50% infill is recommended. And for very high strength prints, you can print at 80% or even up to 100% infill. Of course, this leads to more time and more material used for printing your items. I wanted to show you examples of what infill looked like at different percentages. All the way on the left is our 10%, going all the way up to 80%. I'm sure you can guess which one of these 3D printed parts would be more strong than the other. Be sure to spend some time with some of the additional settings in MakerBot Print if you're interested in deviating from the default print modes. Each one of the default print modes will automatically update, the roof and the shells and the infill, but spend some time looking at them. We are going to pick the balanced mode. We'll add a chamber temperature of 35 degrees. We'll change infill to 40%. Temperature is usually indicated on the rolls of filament themselves. You can get away with 215 degrees for most applications. The base layer is the first layer that is put onto the build plate. Because 3D prints are built off of each layer previous to it, the base layer is really one of the most important parts of your print. You can choose to have no special base layer, a padded base, and so that's going to be a thicker plastic laid down to help adhere to the build plate. You could also do a padded base with a brim. To conceptualize a brim, consider the brim of a hat. It is more filament that's laid down around the object in order to help it adhere to the build plate. And lastly, you can have a raft, which will lay down multiple layers on the build plate, and your item will begin printing on top of those layers. Here you can see the image of a raft. There's a letter I on top of this plastic built for it. And at the end of the print, you'll actually remove that I from it. Using a raft can actually provide a higher quality base layer. Again, you can see explanations for each of these base layers if you go into the custom settings in MakerBot Print. Many 3D printers have a heated build plate, which helps that first layer adhere to the build plate. The MakerBot Replicator Z18 doesn't have a heated build plate, so it is important to use either a padded base with brim, or a raft to make sure that your print adheres to the build plate. I wanted to show you some examples of the same print, but with different base layers. All the way on the left, you can see if you have no base layer, this print will not adhere to the build plate. With a padded base with brim, and with a raft, it certainly will adhere. Whether you use one of the 3 preset settings on MakerBot Print, you will have to decide if you need to add supports or not. So supports are additional structures that are used to prop up any sections of a print that can't stand alone. They're going to be automatically generated by the slicer MakerBot Print, so you don't have to worry about designing them. We need supports because of the way the 3D printer prints. Consider a hot glue gun laying layer upon layer. Where do you think the hot glue gun is going to struggle to finish the print? Supports are required for bridging and overhangs. Take a look at the bridge and take a look at our stick figure person. I want you to think about where the printer might have trouble printing and where a support might be needed. Our stick figure hands give a great example of an overhang. It's unsupported, and if you just print it, it might fall off. On the bridge, you can see a good example of bridging. To get a better idea of whether or not you need supports, think about the ABCs or the YHTs of support in 3D printing. A Y can be printed without support because it has a 45-degree angle. An H shows a great example of bridging. Now, the general rule is if the bridge is greater than 10 millimeters, it will require support. But if the bridge is less than 10 millimeters, you don't need to worry about support. T is a great example of overhangs. The top of the T is only supported in the middle, and without support, the plastic could fall down. Now, the rule about overhangs is that if it's under 3 millimeters, you can print it without support. This is what happens when you print overhangs and bridges without supports. On the left-hand side, you can see that the ends of the T, it kind of sags a bit and the print is all over the place. If this was a large-scale print, your print itself could tip over. It could lead to problems and really a dangerous situation without support. In the case of the H, you can see that it's a very sloppy looking H. It's saggy here in the middle, and it's in need of support. In the case of the palm pen holder, we don't need support. But let's pull up an example where it would be important to have supports. Here's a simple letter I. When the I is being printed standing up, it actually will need support. So in this case, you would press this button for support, and then you can view the print preview. and it'll show you what the finished product will look like with its support. The print preview also shows the time estimate needed. Let's run a print preview of the Palm Pen holder that we're looking forward to printing. We've got our raft on, we will not need support. Infill density at 40. Let's run this print preview. This item will need 3 hours and 17 minutes to print, and you can watch it as it would be built up layer by layer. So we have our print ready to go. How do we get it over to the printer? There are 3 different ways to transfer your .MakerBot code to your printer: wirelessly, wired, or with a flash drive. To wirelessly connect to the printer, make sure that you're on the same network as the printer, and come to the bottom. You would click Add Printer, and you can connect via IP address that is in the settings of the printer, or you can just press Add a Network Printer too. To connect with a wired connection, use the cord that is included with the printer, or you can export your file to a flash drive and then plug it into the printer. In this case, you would click which printer you have, the Z18, and you can export it to the flash drive. I'm going to show you how I connect to the printer wirelessly. Once you click the printer on the list, you'll see a camera of the print, and it'll say that it is ready to print. And go ahead and press print, and the print will be transferred over to the MakerBot Replicator Z18. Be sure to have the clear build plate before you get started. It's a good idea to watch the printer, especially during the first couple of layers, to make sure that the rest of the print is going to go as planned. You can either watch the camera on your computer or download the MakerBot app and watch the camera on your phone. When your item is done, it is time to remove the item from the build plate. On the bottom right hand, you can see that we have a completed Palm Pen holder. To remove the build plate, turn the orange switches and then pull the build plate straight out. Sometimes it can be difficult to actually take the print off the build plate, so try using items like a spatula or kind of shifting the print around to get it moving. After the item has been removed from the build plate, consider if you need to do any post-processing. In this case, we had to remove the raft, and some sanding was necessary to make sure that the item was smooth holding in somebody else's hand. The OTD program has different tools that you can use for post-processing. I want to leave you with 2 bonus tips that I found to be helpful when using the printer. When loading the filament, try cutting the filament tip at an angle because it helps it feed into the extruder. And lastly, make sure to allow the printer to cool down before turning it off. It has a fan that starts turning on, and if you turn it off before the fan cools it down, then it's going to slow down very, very slowly on its own. Here's a list of the references used for this presentation. If you want to learn more about this printer, I would refer you to the Z18 manual that's available on MakerBot's website. I included my email address at the beginning of this presentation, so please feel free to email me with any questions that you might have about this 3D printer, any other 3D printer, or some of the applications that I've used 3D printing for in occupational therapy. Thank you so much, and I hope that this has been a practical guide to getting started with the 3D printer.